Hello, Mike here at GameFromScratch, and today we are going to look at making a very crappy, very unpolished, but very complete physics-based 2D platformer using the Duality game engine. In that, there will be a platform. You will have it controlled by physics, and it will work in 2D. I'm not going to get into a whole lot of polish because I just want to show you the process. Basically, it's sort of like a teach a man to fish moment. Once you've seen how to do all these things, you can obviously make a much more complex game out of it. So we're just going to cover the technical details. Now, if you've never heard of it, Duality is an almost criminally underrated, underexposed game engine out there. It is Windows only for tooling, unfortunately. The back end is OpenTK, so you'll be able to port it to any mono-esque platform out there, but the tooling itself is all entirely Windows-based. So that's obviously going to be a turnoff for some people, and it is a 2D game engine. Completely C# powered, but it is pretty awesome. It's component-based, full editing environment, MIT open source license, completely free. If you're not really up to date on your open source licenses, basically as an end user, MIT is the best one. Basically do what you want, however you want, whenever you want, however you want. Did that one already. Whyever you want, just don't blame us if you accidentally blow up your house. That is in a nutshell what the MIT license is. So it's probably one of the most liberal licenses out there. You can just do what you want with this source code. You don't really have to credit anyone, you don't have to contribute to it, but obviously it'd be nice if you did both. So that is Duality. If you're interested in learning a bit more, I actually did a closer look at feature on this guy about a year and a half back. Not a whole lot's changed since, so it should still be up to date. I will link this video and the text version down below. I'm also doing a text-based version of this tutorial. So I will link that down below as well. So if I lose you at some point in time, because I'm going to try to go through this pretty quickly, if I do lose you, don't worry. Check the step-by-step text-based version once it's published, and you will probably be good to go. Or, of course, I suppose you could rewind and listen again. If at that point in time I still haven't answered your questions, let me know in the comments down below, and I will do my best to address them. Because this is a game engine I do want more people to be exposed to. So without further ado, let's jump right in. And we're literally doing this from scratch. I'm earning my name game from scratch on this one, because we are starting from downloads. So basically go to the website and download the editor and go over here, show it in folder, extract out the zip file, and it is about 1 megabyte in size. Where are my extract options? Come on. There we go. 7-zip, extract to the Duality folder, and then run the executable Duality Editor, and this will in turn give you the MIT license that you have to accept and download the various bits and bobs that actually are required for the engine. So the various libraries it depends on, such as OpenTK that I mentioned earlier. This takes less than a minute, so we'll just let it run. I'll babble in the background while this is happening. All right, there we go. So now the editor is up and ready to go. It's called the Duality. Fire it up. I'm not going to get into an explanation of, here's what this button, this panel does. Very configurable. This is a component-based engine. So if you've used the likes of Unity or actually pretty much any modern game engine for the most part, you probably got a pretty good idea what we're dealing with here. Your scene graph is here, your assets are here, and your basically on-the-fly forms for whatever kind of asset you have selected will appear here. And this is help. And of course over here is where you do your scene composition. And yeah, let's jump right in. First thing we're going to do is actually have to add a couple more functions to the editor. It's implemented in a very modular way, so it's not all you can eat. If there are things like, say, tile maps, which is what we're going to use today, not all games need that, so they've implemented them as plugins. So going on to the online repository here, and we just want to go ahead and add 2 plugins. The first one we want to add is the tile maps editor. Install that guy. Tile maps core, and install that guy. So now we have tile map functionality inside of our browser. I assume that one went. Let me just make sure that those happened. All right, so in tiled we have tiled map editor and core are now installed, so we're now good to go. Those functions and menus and various other bits and bobs will now be available to us. Let's get started. We're going to start things off really simply. So you see here we have basically a game object or entity in common parlance, and it's got a camera, a sound listener, and a transform attached to it. We're going to set this guy up. We'll configure it once we have something to point at, but we're going to want to move this guy back down the z-axis a little bit. So we'll start with -500, but we're going to actually want to tweak that a little bit later on. We're also going to change the way this camera works. It's not a parallax perspective, it's flat perspective. That means basically as things get farther away, they don't change in size. So we should be good to go there. Now what we want to do is have some kind of a background image to start from. And our background image is not there, not there. All right, I temp. Yeah, here we go. Right here, I got most of this from 2dgameart.org. You can grab all the assets available there. In addition, the animations we're going to be using are from the Game from Scratch patron. So if you're a patron backer, they are part of the art assets. They're in the art, character, animations, or something to that effect folder. And yeah, so what we're going to do is grab background image, which you can see in my trusty image viewer is just a pixel map background. We will bring that guy into Duality and drop it into the project view. This will create a pix map for us, like so. We grab said pix map, drag it into our view, and it will automatically create a new game object with the same name as it, called BG, which is background, and it automatically created a sprite renderer component for us and a transform component. So this can be positioned in space. And that's what we're going to do. We're actually going to move this just slightly off the z-axis so that we can layer things on top of and beyond. Remember, the camera is at -50, and 0 would obviously be normal. So basically, 1 would be slightly behind 0, etc., etc. So we want this obviously to be in the background. Actually, let's move that slightly farther back. We'll put that 5 back. All right. So now the next thing we want to do is we will grab this guy. You will see here the dimensions are 1,000 wide, 750 high. I'm just going to go up here to user settings, default user data, and just set our coordinates to match. So basically our window is going to be the same size as our background. And we're going to have to do a little bit of positioning with the camera to get it so that it frames it right. But let's go ahead and see how this runs. So let's hit run. You do need to have Visual Studio of some form installed in the background. It is a requirement, Visual Studio 2013 or better. You might be able to get by with just the build tools. Visual Studio Community is now completely free and works just fine. For this example, I'll be using 2017. But like I said, 2013 and up is the requirement. And there you go. Our world has a background. We're good to go. Let's continue on. Very simple so far. Things are, progressing fairly nicely. Let's go ahead and exit that out. So now we're going to want to create one more character. This time we're going to have a default animated... Actually, no, we're not going to do that. We're going to do a background thing. So I'm going to show you the programming process on the simplest terms before we get into our player character. So let's add a cloud to our world. Go on back over to our graphic images, back to others, and you'll see we have this file here called cloud. So again, drag, drop, create, bring it in, create an instance, and now we have a cloud. And we can position this guy here. We want this to also be in the background, but not as far back as the background itself. So we now have a cloud in the world. Go ahead and run that. And ta-da! Now, one thing to keep in mind, and I don't use it that much, first off, because build is fast as it is. You've got a preview option over here so you can play with settings and see them in real time. Just do keep in mind, just like Unity, anything you set while it's in play mode will be discarded when you leave play mode. I hate that. I screw it up all the time, so I almost never use it personally. But the option is there. I almost never use it in Unity either, to be honest, because I just screw up so often. But if you're used to it in Unity, you'll understand how it works here. It's basically a quick, dirty scene preview where you can tweak around settings in real time and see the outcome. Okay, so now that we have our cloud in the world, let's add some logic to it, because everybody likes logic. So come on up here, see this C# icon, click it, and this will load the project in Visual Studio for you. You might be able to get by with Visual Studio Code or Xamarin Studios. I don't actually know, because I have Visual Studio installed. It should be invoking it right now. I don't know why it isn't. I'm going to click this button again, and then it's going to probably get mad at me for... Okay, I might have misclicked, who knows. Or I might get 2 copies of Visual Studio running in a second. We shall find out. Alright, so it is creating a project for us. It's basically creating your game as a plugin that loads into the editor. You'll see here it created a your custom component type.cs file for us. The first thing we want to do is rename that to something less crap. So we will name that instead cloud controller. But otherwise, we're good to go. You'll see here that your component is inherited from type component, but we also want to implement an interface. And this is basically where your game loop comes in. So there's CMP, and there's various different component interfaces you can implement. So if you need to have an initialization code, you initialize initializable. What we want is updatable. And basically, this is a function that will be called every single time through the game loop. And this is where you add game logic. So hit Alt-Enter here and implement said interface. All right, so here we go. So all we want to do basically is have this cloud move across the screen with great excitement. So we're going to add a little bit of coding logic here. Nothing complex, but you're going to get an idea of how the coding works. We're going to get on a little bit more complexity when we get our player controller going. But this shows you probably in the simplest example of what you could do. So this.gameObj.transform, so we're accessing the transform component of our game object. Every game object will have a transform. Move by new vector to negative 250, so 250 pixels to the left per second. So what we have to do is normalize that. So we're going to get the amount of time that's happened since the last time to the update call, and that is available in time.lastDelta, which is returned unfortunately as seconds. So we're going to divide that down to get milliseconds, and 0 on the y-axis. Oops. All right, so there we go. So basically all this is saying is move by 250 pixels to the second to the left. And we'll keep that simple for now. Go ahead and build that. And the cool thing is we can actually run our game directly from here. So hit start, your game will load. And you're not going to see anything happening because our cloud component is not hooked up to our clouds. And let's do that next. So we're going back into the editor. Let's select. We also want to turn it into flat so it's consistent. All right, so select our cloud like so. Go add new, and you'll notice now there is Duality underscore. Where is that coming from? Well, if we head on back to our code, that's our namespace. So all of your registered plugins will show up underneath the namespace you gave them. All right, head on back over. So Alt, new, Duality, Cloud Controller. And if we wanted, we could expose properties here. I don't need to. I guess we could expose the speed value out if we wanted. You could control that directly in the editor. But in this case, very simple. Keep it simple. Let's go ahead now and run our game again. And there goes our cloud at 250 pixels per second, screaming off to the left, and away it went. Now we're going to add just a small bit more logic to that before we leave here. And all we're going to do is basically have it scroll back to the right once it's gone significantly off screen. So if this.gameObj.transform.position.x is less than negative 600 pixels, like so, then this.gameObj.transform.move to, so we're literally teleporting this object to this pixel location, 1000, this.gameObj.transform.pos.y-axis, like so. Oh, what do you not like? Oh, I didn't actually create a new. Just a sec. New vector 2. And let's close that. Go ahead and run our code. All right, why are you mad at me still? Okay, not mad anymore. There's a weird lag in Visual Studio 2017 about getting rid of warnings. All right, without further ado, there goes our very, very fast guys. Off they go, and then back on through. Now, one thing we probably want to change a little bit is our clouds are a little opaque. So we can head on in, grab them. I believe it is in the texture itself. RGBA, linear, Oh, it's material. Main color, select it, and we'll just set our alpha value to 50%. All right, so now we have slightly more transparent clouds, look a little bit more, let's say, cloudish. All right, so now we have our background, we have some cool parallax things going on in the background, sort of. Now let's, should we move to the foreground or should we move to our character? Let's start off with the character. So first things first, let's bring in just a default animation for it, and that's where idle comes in. So you see idle, we've got 2 sprite sheets in here. We'll go ahead and grab the one I've reduced in size by 50%. And really all it is a bunch of same-sized images in a sequence. So basically we've got 15 images here that put together like a flipbook style, make an animation. Let's bring that guy into Duality, drop down here, and now we're going to do things a little bit different. So far we've basically been dragging it up there, and that created a sprite renderer for us. We want an animated sprite renderer in this case. So before we move on, let's tell this guy that this is actually a multi-frame animation. So there are 4 columns. Yep. There are 4 rows. Yep. All right. So now that we've got that, go up here, new game object, and this is going to be our player. And let's add new. First off, we need a transform, and we need a graphics animated sprite renderer, like so. So you see your default graphic is not quite looking right. What we want to do is just bring our pix map over and create that as the material. And there we have it going good. So you'll see our default time to play this entire animation is 5 seconds. We'll switch that down to 2. At 15 frames, this works at about 7.5 frames per second. For the playback speed, starts at frame 1. There are a total of 15 frames. And let's preview that. So there you can see our guy sitting there, off in space, kind of tapping his foot, playing things idly. So now we have a player character to work with. We have animated sprites that are transparent. We've got a background image looking good. Next up, we need, I don't know, a world to interact with. And we're going to do this with the tile maps. Now, I'm going to make literally one tile in our map world, but you'll get the gist of exactly how this works. So first things first, we need a tile map to work with. A tile map is just another texture, or they call it a tile set in this case. So you can see here, 32 by 32 pixels for each particular tile, a bunch of squares to go together, use those to draw the world. I got all these from, I believe, 2dgameart.org. I don't know if I've said that already, but that's where a lot of these assets came from. So grab that, bring that over, drop that into here, and create it. Now, this is where we installed those plugins before. If you do not get this menu, when you right-click and says Create Tile Set, if that menu is not there, your plugin did not install correctly or you haven't done that set yet. So I'm going to go ahead and create a tile set for it. You see the tile set, you'll see it's 32 by 32. We're good to go there. And now there's a couple ways we can go about doing this. We can just drag our tile set into our world like that, and it will create a tile map renderer for us. And we can then go into the side of that and grab the tile map here. But we actually want to make this guy a little bit more complicated. So when we grab this guy, right-click it, we can open it in the tile map editor. There's a guy up here, first off. We're going to set up our tile map. And what I want to do is I want to turn deep tile maps off. I want to have one layer, but I do want it to generate this collision shapes for us. And it's got the sizes set up right for us. And okay. And what it did now is created a new guy called map. So now that map's created, let's get rid of our source like so. So there is our tile map. Open that guy up, you'll see it created a base layer for us, and then a background layer, which is nicely going to have our collision maps in it. So speaking of collision, actually, you know what? I did that out of order. Let's pretend I didn't do all that, and I'm going to do something else first. And I may not have to do this in this order, but I've had some issues in the past. I screwed one thing up. So let's get rid of that guy, and we're going to do all of this all over again. But before doing it, go into your tile set, like so, and double-click it, bring you up in the tile set editor, switch on over to collision info. So define this before you create your map. I don't think you have to, but I have run into some issues in the past before creating everything else. So we're going to do exactly what we just did a second ago, but I'm going to do this first with our tile set. And basically what we're doing is setting up the collision details. We'll zoom in a little bit and I'll show you what I mean. So basically I'm saying all angles from this guy, this guy, this guy, this guy, this guy, this guy, you can't come in at them. You'll also notice I could also define edges. And this is just basically saying where you can walk and where you can't. I'm going to be very simple and basically just say you can't everywhere. So, and then once you've defined your collision layer like that, go ahead and click Apply. All right, so that has set up collision layers for us in the background. We are good to go. Let's head on back over to our tile set, drop it into our map, bring this guy up in the editor. All right, close you, tile map editor. All right, we're good to go. Once again, come up here. It's not a deep tile map. Deep tile map would be if you had multiple layers drawn on top of each other, often used in like a 2D top-down game such as Zelda, where say in the background you might have a layer of grass, and then on top of that you might have a potted plant, for example. In this case, we only have our one layer. We're not doing anything really complex, so we're just going to go back and again, generate that one. Delete our source material right here, and go with the generated, slightly more detailed map. All right, so theoretically, the exact same thing just happened. I just like to do that generate collision maps first before going through that process. So now we've got it. You're actually seeing it automatically does this fill, and I don't know why. I kind of wish it didn't, but it does. And I closed down our tile palette for some reason, but it basically automatically filled your background with the first tile. And that's why I always have a transparent tile available in my tile map. Just grab it and paint. Flood fill, there. So now our tile layer is completely and utterly transparent, which is good. Now we can use that to layer tiles into our world. And let's see, we'll go on back. In our tile map editor, we have the option of showing things from the world. So we can show, rigid body shapes, background plate, etc. Or we can come on over here and actually bring objects in from the world. So the sprite renderer is our background. I can click that and you'll see, oh, okay, that works out well. Now you'll notice here, there's this outground layer. That's basically going to be our collision layer. So this line right here from our tile map, that's the boundary of our tile map. And our tile map automatically gets this bounding rectangle around it, which is good because that's actually going to be our ground. Our player is going to walk relative to there. So once I hook physics up, that's actually where he would fall to. And you know what? That's a good segue. Let's switch over to that now. So let's go back to our player, add a new component to it, and we are going to add, switch this back out to the scene editor, player, new component, physics, make it a rigid body. Now a rigid body is basically makes this a live object in our physics world. We're going to keep things mostly default settings. We're going to just change out linear dampening down to 0.6. These are all values you can play with and experiment with. You probably want to actually set your things up to have some real-world logical numbers to them, but I'm keeping it really simple in this particular case. So what else did I change? The biggest thing is I want fixed angle. So I don't want the physics simulation to spin this guy. And that's kind of what we did there. Now we've got that defined. So I'm back in here. I'm going to switch from the scene editor to the rigid body editor. Now our default rigid body is kind of crap. As you can see, yeah, that's not what we want. So let's delete that guy, and we're going to instead grab this polygon tool here, and we'll just draw roughly around the edge. Now this bottom one, important, try and keep it as level as possible, but more or less just kind of outline your sprite. Keep the polygons down. The more polygons you use, the more complicated it'll be in the simulation, but you basically just define to the physics engine, here is how this sprite is shaped. So we now have a sprite within our game world. The game world is now set up and happy. Let's go back to our sprite, our scene editor. Now you got to be careful when you move things in the rigid body editor. You're moving the rigid body, not the sprite it's attached to. So you always want to make sure that you move your object in the right editor. So I want to move this guy, and when I move it, the rigid body is parented to it, so it will automatically move with us. So that's a trap you can run into. So we're going to move him up here, and then as soon as gravity kicks in, see, wow, we fall. And then there is the tile maps, that border I was talking about, acting as the bottom of our world, which is good to go. We're happy with that. Things are looking pretty solid. So now where are we going to go? Well, let's add a tile into our world. So a tile map, and I'm not going to, this is where platforming would come in, but I'm going to keep the platforms very simple. In fact, I'm going to create exactly one. So go back to our map, like so, our base layer, or our only layer actually, and we'll open it in the editor. And now we're just going to basically draw where we want our tiles to be. We'll grab that tile right there. We'll go into paint mode right here, and we will create one tile. Now, if you're feeling very adventurous, if you really want, you could go ahead and create, say, 2 tiles. Or if you're really brave, 3. But really, I just want one. So, oh, is there an eraser? That might have been stupid. All right, I'll just paint over those with the transparent. So this is also, again, why you want to have a transparent tile available in your tile palette to get rid of your chases, because I don't actually see an eraser option in here, which is a little strange, actually. So now we have a tile on our world, or a platform. So like I said, physics-based and platforming, we're already there. We have physics and we have platforming. So you can see, now if I move this guy over instead to where our platform was, like so. So not in the tile map editor, we go back to the scene editor, we grab our daunting hero, and we drag him over to the right, and we go ahead and run that. We are going to fall and hit the platform, like so. Now I have that fix turned off, so if I go ahead and change that, so I grab our player, the rigid body controller on him, and turn fixed angle off, we will get a much different simulation. And we don't want to fall, because there's no logic in here for getting back up. So that's why I turned that fixed angle off before. So let's turn that back on. So basically just says, don't rotate this guy. Okay, physics engine, please just don't rotate him. But we're getting there. We actually have our world, a tile. We could add as many tiles in at this point as we wanted, but realistically, we're getting there. So let's go back. We'll take a look at the rigid body editor again, and you'll see the actual, the tiles are being created for us from the tile map collision we defined in our tile set right here. When we define these collisions, those are automatically being created when we paint our tiles. You'll also notice there is an option. Don't remember where it is. It's world geometry, tile map collider. All right, you have to come into the tile map collider. You can turn rounded corners on or off. Man, that's about the extent of your options. But that is your world. You can also do depth, auto tiling, way beyond what we're going to cover today. If we're doing a full tiled game, I would show you how to do these. Just do be aware, there is a great deal more complexity available behind the scenes. But now let's go ahead and add some logic to our main character. This is going to get us a lot more into the coding world. But first we need a couple more assets available for doing that. Basically right now all he can do is stand around, which isn't ideal. We want to also go ahead and give him the ability to jump and the ability to walk. So first let's grab jump. Go to our editor, drop that asset in, which by the way, I am being a complete slob here. You can organize these guys down to folders, so you can go here, create new folders. You can put all of your backgrounds into a background folder, etc., etc. Your scenes into a scene folder, or you can organize by scene, however you want to do it. I'm just doing everything. This is like basically filling my C drive with crap, which I also do in real life, so not a big shock here. But you can organize things a hell of a lot better. You'll also notice there's this default here. These are just the built-in assets available to every game. So for example, if you need a font, there is a font available in here. You need a texture, we saw the Duality logo earlier on. It's available to play with. These are just built-ins that are available for you under the default folder here. Okay, so I brought in jump, I brought in idle. Now I just need to bring in jump, idle, and walk. Okay, so they're just different setups of animation. So you can see this guy, let's define its boundaries. It has 2 columns. Don't know what I just did there. All right, 2 columns, and that would be 5 rows. And our jump is 4 by 4. That's a 5. Let's try that again. 4 by 4. Okay. And I don't know if this step is actually required or not. I'm not oops, I missed. See how this guy has a texture and a material generated for him? That's because we actually used it in the scene. I don't know if I need to create them for this guy, but I'm just going to go ahead and do it anyway. So just drag them into the scene. Those other files will be created for you because we're actually going to use them in code in a second. So I'm going to make sure that a texture and a material are created. This will probably be created on the fly from the code side of things. But you know what? I just want to make sure that it actually happens. So jump, get rid of that guy. All right, so we have all of our assets available to us now. Let's switch back over and do some coding. All right, so we're back here. So we had our cloud controller that we created earlier on. Core plugin is created for you. Basically, this is just where your game top level logic would go. And what we're going to do is create another component. So add new, excuse me, new item. It's class, and we will call this guy main. No, we'll call it nuab. Apparently, I'm shifted off one key. Main character.cs. And I'm lazy. Copy, paste, and rename main character. All right, so this guy is also updatable like that, but he's also going to be initializable. So in addition to that guy, we do ICMP initializable and do a control enter, oops, control Z, that would be an alt enter, and implement the interface. That guy, alt enter, implement the interface. On shutdown, we don't do anything. So just, we don't want to throw an exception on shutdown, of course. Update, we will come back and get the logic for this guy in a moment. All right, so now we're going to back up to here. Now, we actually have some dependencies on this guy. So this component can only be attached to game objects that have other components available on them. So we want to actually set that up as an enforceable rule. And that is done with the attribute required component, like so. And we want type of, and we want duality dot components dot renderers dot animated sprite. So basically you need to have an animated sprite component attached to this guy or basically go away. And we're also going to have a rigid body requirement. So required component type of duality dot components dot physics dot rigid body. So really, all you're doing is basically saying that these components, when in the editor, require these actual components to be attached in order to function. So if you've got mandatory requirements, these are there. Now, also do keep in mind, there's potential those components could still be null. I'm not doing any of the tests here, but do check for null just in case. I didn't. I'm lazy. But if you're actually creating a game, you probably want to do this right. Okay. So those basically say that this guy, main character, requires those two components. Now what we're going to do is some initialization. So we're going to have our 3 different states. So let's create an enum to control them. We'll call it anim. And why are you being so slow, computer? All right. Anim state. And we have idle, walking, and jumping. Nice. So those are the 3 different options we have for our animations at any particular time. And I gotta give you a bit of a warning. What I'm about to do, you're not supposed to hold content references ever. I never ran into any issues for them. I never actually looked up the logic of why you can't do this. You're supposed to do them and use them as locals only. I also am not doing this. Basically, I don't think you can rely on the persistence of these guys. I didn't have any issues. I'm just gonna go ahead and do something I probably shouldn't. But if you have issues, change your code so that it doesn't work this way. Don't hold a reference. Just call each one each particular time. So basically, we want a content reference to a material of type jump. Why are you not there? All right, come on, bring it in. There we go. And so this is going to be our jump material, our walk material, and our already defined, but we'll keep it anyways, idle material. And now we need to go ahead and actually get references to those. Easy enough. In our onInit, once again, I'll put a comment in. You aren't supposed to store references to content ref returns, but I do anyways. All right. So once again, you're supposed to call these every time, each time. I'm just storing them for brevity. It makes things a little bit more readable, but there's supposedly a reason why you're not supposed to do this. You're also supposed to probably check for nulls, which again, quick and dirty example here. Content provider, provider dot request content of type material. So here's basically we're hooking up and saying to these guys, gimme, gimme. So we're saying I want of type material. And the cool thing is if you actually go to the Explorer, you'll see this is generating a bunch of res files for us behind the scenes. So that's particularly, this is the file we want in data res file. So head on back over, back to my code. So that's where our path comes in, and we just go Unicode, so at data/jump.material.res. So load me, give me that file, gimme. And so that's our jump asset. That's our jump asset again, and that's our jump asset one more time. I bet you can guess what I'm gonna do here. Walk and idle. Walk and idle, like so. All right, so really that's all we've done. We've grabbed a different set of materials for each different set of animations we've got. And there's another way you can do this. Their recommended way from their documentation is basically put all your animations in one file and do it index-based. But that's ugly to me, so I went with this route. Okay, so next up we go with Duality app.keyboard. So this is kind of a global singleton type object. It gives us access to underlying technology. In this case, we want the key up event plus equals and then tab to insert. So we basically just add a key up handler like so. So that is going to be fired when a key is released. We will be using that at a later date, but just so you know, it is there. Now we're going to be implementing void walk idle and jump. So those are just functions that are going to implement each of our animation tasks. And without further ado, let's actually go ahead and implement one of them. We'll start with I think walk is the most complicated. So let's start with idle. All right. So idle. On idle, if state not equal. Oh, I didn't create state. Just a sec. I need to implement state. So now we got that guy. That'll control basically what we are currently doing. Are we idling? Are we walking? Are we jumping? So if we are currently state not equals to anim state idle. So in case we called the state the idle function while we're already idling, we're not going to do anything. Otherwise, let's change up our animation. This dot game object dot. Here's how you get a hold of your components. So get component. We'll get it by type. And there's a duality dot components. Obviously, you can use using and make your typing a lot less, but for these examples, I like to go full blown. Renderers. Screwed that up. Renderers. There we go. Sprite renderer. All right, so basically get our animated sprite renderer, store it in a variable called anim. Anim.shared material, and you're going to see the values we're going to use, such as shared material here, just correspond 1-to-1. So let's go back to our player object, animated sprite renderer. So you're seeing here, so for example, we're setting shared material. We're going to be setting animation duration. We're basically just setting these values programmatically. So shared material equals, and then idle, which we loaded up here, dot res, so the resource behind it. Again, that could potentially be null. You should do a test. I am not. So basically set the shared material to the idle set of animations, and then we just have to configure it so that it matches our actual dimensions. So anim first frame equals 0, anim frame count, oops, I missed my dot frame count equals 15, state equals anim state dot idle, anim loop mode equals that guy dot forever loop. See, we're not going to want to loop our jump animation, obviously, so we're going to switch that guy up depending on what we're doing. And then this is going to come for physics for later on, but basically we want to make sure that we're not moving when we go idle. So physics equals this game object dot get component of type Rigidbody. Really, I got to start using duality dot components. Especially when I can't type. Duality.components.physics.rigidbody, like so. And we just go physics dot linear velocity equals vector2.0. All right, so that function there will handle switching us to an idle state. Next up, let's implement walking. Almost the exact same logic to a degree. First off, we're going to make sure that we're not currently jumping. State equals anim state dot jumping. So basically, you can't walk while you're jumping. Otherwise, I want to do this. And we're going to want to do this. Just getting reference to our physics and animated sprite controllers, like so. And now we're going to say if state not equal animation, same logic. Basically, Are we walking already? If so, don't do this. If not, and realistically, we are pretty much doing the exact same thing we just did here with different values. Okay, so already defined you. Don't need you here. Get rid of that. All right, so, oh, walk. So we want to use our walk graphics instead. First frame, how many frames are there in the walking animation? I believe it's 9. Switch that out to 9. Animation state is now going to be walking. Oh, you are going to loop. And you guys are going to do nothing. All right, so basically, if we're not already walking, switch our animation over to the walking animation and loop that sucker. Now we're going to need to do pretty much a direction. So I'm going to be reusing the walk animation for walking left or walking right. And really, the only difference is we're going to flip the sprite if we're going left. So bool right. Are we walking right or not? So come on down here. We go if right. So we're walking on the right-hand side. Then we need to go anim.flip equals duality dot components dot renders renderers. I really gotta start using anim sprite render dot flip mode dot none. So basically, don't flip. So, and physics, and these are numbers you're going to want to play around with. I don't know if my defaults are going to work out nice here, but basically apply a linear velocity. By the way, it's one of those things, this is great for a fun example right here. Trying to control a walking character using a rigid body in physics is generally a really stupid thing to do. What you want to do is set it to a kinematic character and control it directly. But in this particular case, we're going to stick with a rigid body, and it's going to control very, very awkwardly as a result. Just one of those things to be aware of. This is more of an example thing than an actual way you would do things in-game. And that's why a kinematic body exists. And coincidentally, if we go on back here, what I am talking about is the rigid body here. We go down to the rigid body controllers. You've got body types. There's kinematic as an option. And since we're here, actually, what we're all going to do is turn on continuous collisions. So that is going to take more processing power, but give us a more accurate collision detection. And we will do that for this guy here, too. Like so. All right, so that is what we are doing. So linear velocity, and we will move new vector to 5 and 0. So give it linear, move at a constant rate of 5 to the right. 5 what? I actually don't know. I didn't look it up. I don't know their physics units. I just sort of played around to get this guy working, to be honest. And we'll see when we get into the editor if it actually is working or if I'm overselling that a bit. So obviously don't want an if, that would instead be an else. Why did you give me... I hate autocomplete sometimes. Can't live without it, but... Alright, so instead our flip mode is... Oh, is that vertical or horizontal? Horizontal, like so, and our linear velocity is a negative. Alright, so we have the ability to walk and to idle. We'll come back to jump in a second. I'm going to test this out. We've written a lot of code. So let's make sure that we haven't screwed things up. And now we need to go to our update code. And we're going to need access to the physics engine. So we'll grab that guy. Where did update go? On update. All right, here we go. So reference to our physics object, like so. All right, I put this, actually, I don't need that. I won't put that in there. I put angular velocity equals 0 to turn off the ability to rotate, but fixed rotation should do that for us. So I won't put that line in. So var anim, oh, why didn't I just copy you too? Yeah. So we're gonna need a reference to our animated sprite as well in our update frames. And now that we're here, so if duality dot keyboard, so basically we're gonna pull for duality app dot keyboard dot key pressed duality dot input dot key dot let's do left first. So, all right. So if we press left, walk, false. If, all right, I really got to take advantage of the power cut and paste. True. And our key up, this one basically is saying if we let go of the left or right key, let's switch to an idle animation. So let's put that logic back in there. So if e.key equals duality.input.key.left or e.key key equals duality.input.key.right. So if the left or right key was just released, switch to the idle animation. All right, so that's a lot of code. No doubt I screwed things up. Let's find out how badly. Compiled. Hey, that's not bad. All right, so we just dropped into our world. We're idle by default. Let's press left and see what happens. Nothing. Right. Nothing. All right, so definitely some kind of a negative here. First off, let's move our guy so he's down on the ground. Back to the editor. Back to our camera. Back to our scene view. Scene editor. Let's grab our guy and move him there. Let's make sure that that isn't a factor. It shouldn't be. Oh, I'm an idiot. All right. So, did all that nice coding. I didn't actually hook it up to our guy. So, duality, main character. All right. Much better off. Let's run our game. Now we fall into the game world. I press right. Ooh. All right, so we apparently have a bit of an error on our graphics call, but our movement seems to be working fine, which is nice. So let's figure out what mistake I made with the loading of materials. Jump, walk, idle. Oh, there's the 50s. It's probably this. See if I get it right on the first shot. We'll run our code. There we go. We can walk, and we can walk. Yay! And we can collide with our object. Everything is looking perfect. Now all we need to do is give the ability to jump. And we have ourselves a platformer. This is actually pretty cool accomplishment for 47 minutes as of yet. Especially considering the actual game time. This probably took me about 25 minutes to get to this point. So I hope you're starting to see some of the power of what Duality is capable of here. And the programming model and the methodology and everything behind it is actually pretty simple. So this is, I don't know, I like this engine. I think this is an engine that more people should be aware of. And hopefully it's impressed you so far too. Now, my coding perhaps may not have impressed you all that much, but yeah, oh well. Let's go to our jump logic now. Jump. All right, last thing we've got to do, going to jump. Jump is going to consist of, oh hell, it's mostly this. Right, if we're already jumping, if we're not already jumping, set up jump. Jump, I believe, is 15 dot jumping. I think it's 15 frames as well. We want to switch that animation out to jump.res, like so. What we do not want to do is loop. That will look weird. So that is once. Physics, yes, we're going to do the physics. Linear velocity, no. Instead, what we're going to do is a lot of physics. So we're going to have the same logic as before. So basically, we want to check to see if we're going left or right. And that is done via if anim dot flip equals duality dot components dot renderers dot anim sprite renderer dot flip mode dot do I check for or not? Okay, so if we're going right, let's use this logic, else this logic. All right, so on the right hand guy, we want to physics dot, instead of an impulse, we're going to apply, sorry, instead of a linear impulse, we're going to apply a single impulse. Again, play with these numbers, apply local impulse, new vector2, and then 7200 something, and 1550 something. So that's forward and up impulse that we're applying. Again, you're going to want to play around with those numbers. If we're going in the opposite direction, we are again applying it in the opposite direction, like so. And let's go back to our world and see how our jumping works, if our jumping works. All right, so we're in our world, press space. Oh, I didn't wire it up to anything. Duh. All right, yeah, so maybe we should actually jump when we, let's say jump. So we need to go back to our update function. Update. Ah, here we go. If duality app dot keyboard dot key pressed duality dot input dot key dot space. So if we hit the space bar, jump. There we are in a world, walking left, walking right, left and left, walking right, and okay, we have a bit of an issue. Let me just try jumping before I walk. All right, our jump is certainly not correct. I'll be right back. All right, I missed a little bit of my logic. Basically, what I want to say in my update, so I can start jumping, but jumping is a one and done. So what I want to be able to do is say if state equals anim dot anim state dot jumping. So if we are jumping, so this is a test each pass through the game loop. We say if anim dot current frame equals anim dot anim frame count 0 base, so -1. So if we're on the last frame of animation for the jump, well, we should stop jumping. I don't think this is actually what my error is, but this is logic I do need to have in here. So let's, after we're done jumping, we'll switch to the idle animation, or you can switch to the walk animation if you so wished. And then for our physics, basically let's just stop moving. So no more angular velocity, and physics dot linear velocity equals new, actually let's do vector2 dot 0. All right, let's see if this helps us out at all. Jump. Whoa. All right. Jump, 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 jump. We have some issues. We're jumping, but we definitely have some issues. One thing I want to change out is our jumping animation is way too fast. I thought I set that in the if jump anim. I didn't set the times. Okay, anim dot duration equals 2. All right, so now we need to do is probably just tone down our jump amount just a little bit. So let's go with 4,000 up and maybe 8,000 forward. right, that's a lot of forward and a lot of up still. Did I get my dampening different between? I don't know why these values are coming up so much different than my original settings. What if my mask was different on my case? Just 1 second. Okay, not really sure why this is different, but in my other example, I have my mask set 3 times higher. All right, so we can now jump, and we can walk while jumping. So a little bit of my logic's gone, but I don't want to in the end, to be honest, this is a matter of, first off, why you don't use physics for controlling your character in a situation like this. All right, and I'm able to pass into that guy, which I need. Oh, I think I need to turn continuous on for him too. I thought I did. But anyways, we've got the basics of a platforming game on here. Our controlling logic is a little wonky. Let's do one last shot at this and change this guy down to about 3,000. I could actually have done a little bit more research on what the physics units are and set this guy up so that it actually made some kind of sense as opposed to just playing around with the numbers. All right, way too much forward, way too little up. So let's go with ooh, that's barely any forward. All right, there's something very wrong with my logic. Doesn't particularly matter. You get the gist of what we're trying to accomplish here. I make sure that whatever I do in the text-based version and links down below has values that actually work. I've misconfigured something somewhere, so we're getting a lot of excessive speed here. And it's actually going up, which doesn't make any sense. But as you can see, in our particular world, we have a physics-controlled character in a platforming environment in just under an hour. Complete lack of polish, a bit of an idiot. He's very, very speedy. But you do get the idea of what we're working with. Again, in reality, you wouldn't have your player character controlled using physics as a rigid body. You would have it as a kinematic body and control this using logic. But I found this fun, so I went with it. But there you can see, we've got animation state changes. You let go, we switch back to the idle animation. I'll work out the kinks on the jump, and in the text-based version, you will see the difference. But basically, that is a physics-based, I didn't even have left working right. That is a physics-based platformer, sort of, with a lot of issues. But that is what I promised we would cover. That is essentially what we have covered here. It is just under an hour, and I will wrap it up now. Again, I will clean up some of the glitches we had with the physics at the very end there when I do the text link down below. So check there for full details. But I think you have the idea of what we're dealing with here. And really, other than music and scene changes, we've basically covered every single asset or aspect of a game that you would need. And you know what, I'm going off script for a second here, but adding music should actually be no, I'm not going down that road. But music is just another component. So some here, you come in new sound, and you can do a sound emitter. Remember that our camera already, I'll show that quickly, but I'm not going to get into it. I don't have any sound files set up to show you. But here's how you could add music to your world. Sound emitter, here on this object, bring a sound in, so new sound, audio data, or a sound. Either of those, bring them in, use them in the scene like normal. It'll come out of the background, so I would attach that into this entity over here. And then you saw earlier when our camera was created, it has a sound listener attached to it, and right here. And that will listen for and render the audio. That way you can have positional audio, etc. pretty easily. So that's an aspect of game development I didn't cover in this particular example, but you know what, if you run into problems with it, let me know. I can maybe do a quick tutorial after the fact on it. I'm going to finish this guy off. We're at 59 minutes. I'm going to probably babble for about a minute more. We'll get us to 1 hour, which is about perfect for covering as much as we did. So in summary, I want to say, if you haven't checked out Duality, do so. It's an awesome little game engine. It does not get the attention it deserves. A lot of times, you know, you could do everything we just did in other engines. You can do this in Unreal. You can do this in Unity. You can do this in Godot. but is it overkill? You have access to so many more tools than you need. If you just want the ability to work with tile maps, animated sprites, audio, the things you use in most basic, simple 2D games, is this not enough for you? As long as that Windows only tool caveat isn't a big issue, this is an engine I do recommend you check out. And that's it for now. That's where I'm going to leave things off at the 59 minutes 40 seconds mark. I hope you enjoyed that. If you did, please do click like. And of course, we cover all kinds of game development stuff here. Tutorials, sometimes on game engines people have never heard of. And there's a reason for that. I want to promote the underdog. I want to promote the little guy. I want you guys to be aware of what the options are out there. Hope you did enjoy that. If you did, please do click hit subscribe. All right, that's it. I will see you all later. Goodbye.